Hey everybody, Mr. Odom here, and I am going to go over section 5.3, writing proportions. As always, you need pencil, composition book, or notebook paper to take notes, and a calculator. The learning target for this video is I can write and solve proportions. So let's get started. Draw thing up there. All right. So the big idea in this in this section is if you have to write a proportion, um, using a table to kind of get your information organized is a good thing. We like this. We'll even put a little happy face right here. Okay. And because if you do this, then there's a couple different ways that you can write a proportion. One is you can focus on the column. So let me get something to highlight here. You can focus on the columns. 2 ringtones for every $6 equals 3 ringtones for every X dollars. So you can write a proportion like that. Another way you can do it, let me get some more ink down here, is we can focus on the rows, where I can say 2 ringtones to 3 ringtones, which I do here, is equivalent to $6 for every X dollars. Okay, which one are you going to use? That's totally up to you. I like using the columns. Why? Because this looks like a ratio already with this line right here. It looks like a ratio. So I like to use the columns. All right, so let's look at an example. So a chef increases the amount of ingredients in a recipe to make a proportional recipe. So those are important. Making a proportional recipe, remember a proportion is an equation. So if the chef has some ingredients, certain amounts of ingredients, and he wants to increase them, he wants this black bean soup, if he makes a larger batch of it, to taste just like it would if he used the original recipe. So the new recipe has 6 cups of black beans. So what do we want to do? We want to write a proportion that gives the number X, so they tell us what the variable is, of tomatoes in the new recipe. All right, so what information would be important in the recipe? Well, I know the new recipe has 6 cups of black beans. Well, the original one has 1.5 cups. And the original one also has 1 tomato. So if I go back up here and I see how this table is made, I could probably make a little table that has the information that I need. So I've got my black bean soup. Let me get a pen here. Okay, so let me make a table. First I got to get my pens back here. So my table might look something like this. Maybe I have black beans here. Maybe I have tomatoes. Do any of you say tomatoes? Some people do. Tomatoes here. All right, so I draw a little line there. I'm going to make a little, and then what do I know? I have 2 different recipes. I have the old one, I have the old recipe, and I have the new recipe. So in the old recipe, how many cups of black beans did I have? I had 1.5 cups. In the new recipe, I have 6 cups. In the old recipe, how many tomatoes did I have? I had 1 tomato. In the new recipe, I have X tomatoes. All right, so if I use that column method, where I use the columns to make my proportion, I can write one. It would be 1.5 cups for every 1 tomato. And that equals 6 cups for every X tomatoes. All right, so now I have just written a proportion. So it's important that you can do that, because then we're going to learn how I can figure out what X is. Some of you have probably already figured out what X is. Okay, so let's look at these problems here. Write a different proportion that gives the number X of tomatoes. So basically, here I use the column method, but let's make a proportion using the row method. So I could use the rows, and I could say 1.5 cups of black beans and 6 cups of black beans, and that should equal 1 tomato over X tomatoes. So here I have a different proportion, and what we're going to find, what we're going to learn, is that this will give us another way to find X, and that will actually get the same answers. It doesn't matter which proportion we use. All right. So what about number 2? Write a proportion that gives the amount Y of water in the new recipe. All right. What would we do there? Well, what we can do, instead of in our table, we can make a table, instead of using tomatoes, we can make one and we can substitute water in there. Why? Because we know in our original recipe, we need 2 cups of water for every 1.5 cups of black beans. So let me make a table here that has black beans and, whoops, that's not an S, black beans and the amount of water. And again, I'm comparing the old recipe with the new recipe. All right. I know the old recipe, I needed 1.5 cups of black beans. In the new one, I'm going to have 6. For water, I had 2 cups. And then here would be Y. Can I write a proportion? Yes, I like that column method. So it'd be 1.5 over 2 equals 6 over Y. And then we're going to learn how to figure out what Y is. Some of you probably can figure that out already. So let's look at this example, because this example is going to kind of walk us through how do I figure out what X is? How do I solve this equation? All right, because this is an equation. And actually, it's a similar equation that we solved back in chapter 3. But here's a different way to think about it. So step 1 says the product of 2 and what number is 8. So I think about, what do I multiply 2 by to get 8? And the answer is 4. And then all I have to do is, well, if I want this to be proportional, which means equal, then I need to multiply the numerator by 4. So that tells us that X equals 12. Okay, so, and you guys could have probably done this in your head. This one was pretty straightforward. So we kind of say this is solving proportions using mental math, because you can kind of look at these kinds of proportions and solve them just kind of using math you already know. You guys probably did this in your head. All right, so we're going to do that in this section. We're going to try to use mental math to solve our proportions. So let's practice. Here's number 3. And let's see, number 3 says 5/8 equals 20 over D. All right, so I know to go from 5 to 20, I need to multiply by something. What do I need to multiply by? That's correct. You multiply by 4. So then I need to multiply 8 times 4. So D equals what? Outstanding. D equals 32. Let's look at another one of these. Let's look at number 4. 7 divided by Z equals 14 over 10. And let's see, to go from 14 to 7, I can divide by something. What do I divide by? Awesome, you divide by 2, which means I can divide 10 by 2, and 10 divided by 2 is what? There you go. So Z equals 5. All right, and I just box these up. And let's look at number 6. So a school has 950 students. That's probably important. The ratio of female students to all students is 48 to 95. So that's probably important information. Here's an important ratio. 48 females to 95, and this is all students. So I'll just put A, S for all students. So write and solve a proportion to find the number F of students that are female, okay? Well, we know a school has 950 students, so that would be the denominator. That would be all my students, okay? And I need to figure out what goes there. All right, so to go from 95 to 950, I can multiply by what? Very good, I can multiply by 10. So then I multiply 48 times 10, and that tells me how many female students I have. So 48 times 10 is, man, you guys are good. So the number of female students would be 480 female students. And that's it. All right. So hopefully this was a helpful video for you. If it wasn't, please give me some feedback. Well, it was fun working with you guys. That's all I have for now. This is Mr. Odom, and I am out.